Our lesson today is lesson 46, simplifying expressions with square roots and higher order roots. I think we'll probably all remember what about square roots. What is square root? Well, a square root of 64. Here's the symbol for square root of 64. And what is the square root of a number? The square root of a number is a number that when multiplied times itself will give you this number. Well, what number times itself is 64? I think we all know that that's 8. We'll change colors here. What about the square root of 36? I think we all know that's 6. What about this one? Negative, or the negation of the square root of 9. Well, if we covered the negation sign symbol up, we would know that the square root of 9 is 3, but the opposite of that, or the negation of that, is negative 3. We have a square root of a fraction. We could write that as the square root of 4 divided by the square root of 25. We know the square root of 4 is 2, and the square root of 25 is 5. So the square root of 4 over 25 is 2 over 5. Now, here we got a strange animal right here, strange number, the square root of negative 16. Well, the square root of 16 is 4. But 4 times 4 is positive 16. What number times itself would give us a negative 16? Well, it's not. What about negative 4? Well, negative 4 times negative 4 is positive 16. So there is no real number that is the square root of negative 16. Today we're going to talk about higher order roots. Just a little statement here. If a to the n is equal to b, then the nth root of b is equal to a. Now that's a lot of symbols and words there. But let's just go on, and perhaps we'll understand that better by and by. Let's just make this statement right here. N in the radical, this n right here, is called the index, or the root. If there's no number in that position, if there's no number here, let's say we had the square root of 9, there'd be no number there. It's understood to be 2, or a square root. So it's understood. I'll just kind of dot that in. It's just kind of understood to be 2 there, but we don't put that. It's kind of like when we have 1x. We just understand that there's a 1 here, and we just write x. The 1 is understood. Same way with the exponent. If there's no exponent up there, we understand it to be 1. Okay, so what it would be the cube root of 64? Well, the cube root of 64 is a number that when multiplied times itself 3 times, the root would give us 64. Well, let's think a little bit. Well, let's see. 2 times 2 times 2, I believe that's 8. That's not right. 3 times 3 times 3, that's 27. That's not it. 4 times 4 is 16, and 16 times 4 is 64. So that's the cube. That's 64. Let's write out here. Let's write 64 is equal to 4 times 4 times 4. So we know that the cube root of 64 then is 4. What about the 4th root of 81? Well, what number? When multiplied times itself 4 times, not 4 times the number, but the number multiplied times itself 4 times. What did we do here? We didn't multiply 4 times 3. We multiplied 4 times itself 3 times. So the 4th root of 81 turns out to be, let's see, we could write 81 as 3 times 3 times 3 times 3. Let's see, 3 times 3 is 9. And this 3 times this 3 is 9. And 9 times 9, let's just write those down here. Let's do it like this. That's 9. And then 9 times 9 is what? 81. So the 4th root of 81 is 3. Now, a little strange thing happens. Let's back up to the previous page. You notice that there was no real number answer to the square root of negative 16. But when we get to the cube root of a negative number, is there a negative number that when we multiply it times itself 3 times would give us minus 8? Well, let's see. Minus 8 is equal to, what about minus 2 times minus 2 times, about to run out of room, minus 2. Well, minus times a minus is a plus, times a minus is a minus, and 2 times 2 times 2 is 8. So sure enough, the cube root of minus 8 is minus 2. Roots can be written as fractional exponents. The square root of 4 can be written as 4 to the 1/2 power, which is equal to 2. We know the square root of 4 is 2. So if we know the square root of 4 is 2, then this, since this is equal to this, then this also has to be equal to 2. And the denominator of a fractional exponent is the root. Well, what's the denominator here? Well, the denominator is 2. So we've understood to be a little 2 right here. So that means the square root of 4 is 2. Well, what about this one? The denominator is what? The denominator is 2, so this is the square root of 9. And these are not equal signs, these are equivalent signs. It's got 3 lines. This means equivalent to. So we could write 9 to the 1/2 power is equivalent to the square root of 9, and we know that is equal to 3. What about 8 to the 1/3 is equivalent to the cube root of 8? Well, that would be 2, because 2 times 2 times 2 is in fact 8. What about 81 to the 1/4 power? Okay, well that could be written like this, and I think we've already done the 4th prince, we've done the 4th root of 81, and I think that is turns out to be 3. So here's a little rule. You can take an odd number root of a positive or negative number. Notice that, odd number root. You can take the odd number root. What are the odd numbers? 3, 5, 7, 9, 11. You can take the odd number root of a positive or a negative number. But you can only take an even number root of a positive number. You can't take the 4th root of minus 32 or minus 16, for example. You can't take an even number root of a negative number. You can only take an even number root of a positive number. Okay, so here we go. We've got an odd root of a negative number. Can we do that? Yes, we can. Okay, so the cube root of minus 343, gosh, that's a big number. Let's see, let's try minus 7. I don't know, minus 7 times minus 7 times minus 7. Well, minus 7 times minus 7 is 49, and 49 times minus 7, let's try that, that's 3. It's going to be a minus, 63 carries 3, 343, sure enough, minus 7. Okay, this kind of goes back a little bit. We could write this as the square root. Square root is a positive number. Yes, it's a positive number, so we can take the square root of 81 over the square root of 144. Square root of 81 is 9. Square root of 144 is 12. We can further reduce that to what? 3/4. So that would be our answer. What about the 4th root of negative 16? Remember the rule. What was the rule? We can only take an even number root of a positive number. Even number root. Oops, negative number. Can't do that. So there's no real number solution. Or just no real number solution. Okay, so here's our homework, lesson 46. Let's do 1 through 9, 12 through 16, 22 through 30, and you can either begin on those tonight or you'll work on them tomorrow in class.